The fastest spacecraft speed ever achieved by humans is about 430,000 miles per hour, 692,000 kilometers per h, achieved by NASA's Parker Solar Probe. The distance between Earth and Mars varies depending on their positions in orbit, ranging from 54.6 million kilometers, 34 million miles, at closest approach to 401 million kilometers, 249 million miles, at their farthest. Assuming the shortest distance and the fastest speed, travel time equal sign or about 3.3 days. However, current spacecraft traveling to Mars don't go in straight lines. They follow slower but fuel-efficient trajectories. For example, NASA's Perseverance rover took about 7 months. Cosmic radiation, high-energy particles from the Sun and beyond the solar system, solar flares, sudden bursts of energy from the Sun that can harm spacecraft electronics and humans, microgravity effects, prolonged weightlessness affects muscles, bones, and fluids in the human body. Debris and micrometeoroids, small particles traveling at high speeds that can damage spacecraft. Vacuum of space, extreme cold, lack of pressure, and absence of oxygen. Mars has a very thin atmosphere compared to Earth, about 1% the density of Earth's atmosphere. Its composition is 95.3% carbon dioxide, CO2, 2.7% nitrogen, N2, 1.6% argon, R, trace amounts of oxygen, water vapor, and methane. The thin atmosphere offers little protection from radiation or extreme temperature fluctuations, and it cannot support human life directly. Mars is called the red planet because of its reddish appearance in the sky, caused by iron oxide, rust, on its surface. This gives the planet its distinct reddish hue, visible even from Earth. Living on Mars would be extremely challenging, but not impossible. Key challenges and considerations include habitat. Humans would need pressurized, temperature-controlled shelters. Oxygen. The atmosphere lacks breathable oxygen. Oxygen would need to be generated, for example, via electrolysis of water. Water. Liquid water isn't abundant. Scientists have identified ice and hydrated minerals as potential resources. Radiation. Mars lacks a strong magnetic field and thick atmosphere, so radiation exposure is a major concern. Food. All food would need to be grown in controlled environments or brought from Earth. Gravity. Mars' gravity is about 38% of Earth's, which could affect long-term human health. With advancing technology and the development of life support systems, Mars colonization might be feasible in the future, though it would require immense resources and international collaboration.